Good morning, students. Myself is Srinivas, Assistant Professor, Department of ECE, Kakatiya Institute of Technology and Science, Warangal. Welcome to video lecture on Artificial Intelligence and Machine Learning with Python. Subject code U18AC 502A. Topic Unsupervised Machine Learning Algorithms. In the last class, we discussed about supervised machine learning algorithms. Those are regression techniques and classification techniques. In this class, we are going to discuss clustering, which comes under the category of unsupervised machine learning algorithms. The unsupervised machine learning algorithms are hierarchical clustering, k-means clustering, density-based clustering, fuzzy clustering, and so on. Regarding dimensionality reduction, the principal component analysis algorithm is used. Clustering. Clustering methods are one of the most useful unsupervised machine learning methods. These methods are used to find similarity as well as the patterns among the data samples and then cluster those samples into groups having similarity based on features. The below diagram explains how the working of the clustering algorithm. We can see the different fruits are divided into several groups with similar properties. Here from this figure here, for a particular machine learning model, this particular raw data will be applied based on the features and pattern available in data. The machine learning model will group the data. In supervised learning, the model is trained with the labeled data and then tested with the unknown data. But in the case of unsupervised learning, the data will be directly applied to the model. Just now we discussed the machine learning unsupervised model extract features and patterns within the data to group the data. The clustering technique can be widely used in various tasks. Some most common uses of this technique are market segmentation, statistical data analysis, social network analysis, image segmentation, anomaly detection, etc. Apart from these general issues, it is used by the Amazon in its recommendation system to provide the recommendations as per the past search of products. Netflix also uses these techniques to recommend the movies and web series to its users as per the watch history. The first clustering algorithm, hierarchical clustering. It is based on connectivity. This method follows two approaches based on direction of progress, that is, whether it is the top-down or bottom-up flow of creating clusters. These are agglomerative approach, bottom-up, and divisive approach, top-down respectively. Agglomerative approach. This approach of hierarchical clustering follows a bottom-up approach where the n data points are considered to be a single member of n clusters. That is here the individual data points can be grouped like this. That is here it is agglomerative approach is bottom-up approach. We iteratively combine these numerous n clusters to fewer number of clusters. Let's say K clusters and hence assign the data points to each of these clusters accordingly. Divisive approach. Here we consider all the data points belong to one large cluster and try to divide the data into smaller groups based on termination logic. That is here, the whole data can be considered as a single cluster and then it can be further divided into smaller clusters based on termination logic. K means clustering. It is centroid based cluster. K-means clustering is an unsupervised machine learning algorithm which groups the unlabeled data set into different clusters. Here K defines the number of predefined clusters that need to be created in the process, as if K is equal to, there will be 2 clusters, and for K equal to 3 there will be 3 clusters, and so on. The algorithm takes the unlabeled data set as input, divide the data set into K number of clusters. The value of K should be predetermined in this algorithm. Yeah, the value of K can be determined based on elbow method. Uh, Based on the data, we need to calculate this particular elbow method to determine the value of K. Just make a glance flowchart of K-means clustering. K-means clustering algorithm perform 2 tasks. The first one is determine the best value of K center points or centroids by an iterative process. Assigns each data point to its closest K center. Those data points which are near to the particular K center create a cluster. The below diagram explains the working of K-means clustering algorithm. It is the unlabeled data. Unlabeled data can be clustered based on K-means clustering algorithm. Here, in K-means clustering algorithm, the algorithm takes random data points as cluster centers initially, and then the Euclidean distance will be calculated based on the nearest distance. The data points are assigned to that particular K cluster. Elbow method. Here, to determine how many number of clusters are to be performed on a particular data set, for that we need to apply elbow method, which is done on number of clusters and variance. Here we can observe in this particular plot a elbow position. This position will give how many number of clusters, how to define for that particular data set. The next is density based clustering. Density based clustering methods take density into consideration instead of distances. Density based algorithms can get us clusters with arbitrary shapes and clusters without any limitation in cluster size. You can observe the density based clustering. Fuzzy clustering. In hard clustering, a given data point in n-dimensional space only belongs to one cluster. This is also known as exclusive clustering. K-means clustering mechanism is an example of hard clustering. A given data point can belong to more than one cluster in soft computing. This is also known as overlapping clustering. The fuzzy K-means algorithm is a good example of soft clustering. Here in hard clustering, the data can belong to either cluster 1 or cluster 2. It does not belong to both the cluster. That is the case of hard clustering. In soft clustering, A data point can be belong to more than one cluster based on probability. Advantages and disadvantages of fuzzy clustering. You just make a glance. Next, dimensionality reduction, principal component analysis, PCA. Principal component analysis is a well-known unsupervised dimensionality reduction technique that constructs relevant features variables through linear or non-linear combinations of the original variables. In this post, we will only focus on the famous and widely used linear PCA method. We just go through when and why to use PCA. How the PCA algorithm is to be applied. Algorithm steps. Here, based on the data, we need to calculate mean, variance, covariance, and so on. And then we need to calculate the eigenvalues, eigenvectors for the given data set. And then we need to calculate the principal component 1 and the principal component 2. Now here, what is dimensionality reduction? How it is going on is the given data is in 3D space. The given data is in 3D space. Here, this particular 3D data can be converted into 2D space in such a way that PC1 is one axis, PC2 is another axis. Here, PC1 is associated with maximum eigenvector. It is associated with maximum eigenvector. That is, for a given data, we need to calculate mean, variance, covariance, and then we need to calculate the eigenvalues and eigenvectors for the given covariance matrix. From that, we determine PC1 line, principal component 1 and principal component 2, so that the data can be reduced from 3D to 2D, so that this can be classified easily. You just go through the algorithm procedure. Thank you. We will meet with the next lecture.